Okay, this is the first video for the Chapter 6 review. For number 1, they want us to identify the domain. So with the rational functions, our inputs are going to be fine, except for when the denominator is equal to 0. So I'm going to set x plus 3 equals 0. Subtract 3 on both sides and say x equals negative 3. Now in your online assignments, they would probably write this in the form like x does not equal 3. Here we'll say the domain is all reals except negative 3. In number 2, they want us to simplify the expression. I can factor out a 6 from the numerator and make this x minus 4. And I'm dividing by x minus 4. So these will both cancel. I'm left over with 6. In number 3, we wrote that if we had a monomial, I could break this like 15 over 15 plus 24 over 15. You could write this like n plus, and then divide 15 by 3 to make this 5. N plus 8 fifths. If you look, they'll factor out a 5n plus 8 over 5. Either of these would be true, but we can rewrite when we're dividing a polynomial by a monomial and we're adding or subtracting, we can rewrite this as like 15n over 15 and the 24 over 15. In number 4, when it's x squared minus 17x plus 10, I'm looking for two numbers that multiply to a positive 17 and then have a sum of negative 17. So my options are either two positive numbers that add up to or multiply to 70 or two negative numbers. The fact that the two numbers have a sum of negative 17 tells me that I should have the two negative numbers. I would do x minus 10 and x minus 7. So I can rewrite this like x minus 7 times x minus 10 divided by x minus 10. And so my final answer is going to be x minus 7. When we multiply, it's not a bad idea to factor first and then multiply across. Remember, if it was fractions like 3/4 times 5/7, this is like 3 times 5 over 4 times 7. 15 over 28. This one I'm going to come back to in a second, but when I've got 10x minus 18, I can factor out a 2 from both of these and write this like 5x minus 9. And since I'm factoring out a 2, I'd put a 2 in the outside of the parentheses. This stays x plus 3. Now, it would be easier for us, and most of us are used to seeing like 30x minus 54. In the examples that we have where the numbers first and then we're adding or subtracting, or usually subtracting like some number x, I can factor out a negative 1 to make this negative 54 plus 30x. And then I don't necessarily need to do this in 2 steps, but I can rewrite this like 30x minus 54. So in my denominator, I could have, if I have 30x minus 54, 30 is going to be divisible by 6, and the 54 is going to be divisible by 6. So I can factor out a negative 6, and then this is 5x minus 9. So here, 5x minus 9 and 5x minus 9 are going to divide. The 2 and the 2 are going to divide, and I have x plus 3 divided by a negative 6. Again, there might be some differences in where people are going to put the negative here, but that's how I simplify that one. Same idea with number 6. If I have 6n cubed and 6n squared, I could factor out a 6n squared in the numerator. That leaves me with n minus 1 divided by 6n squared times n minus 1 over, now n plus n squared plus n minus 2, I would factor as n plus 2 times n minus 1 . 6n squared is going to be divided by 6n squared, so I'm left with a 1 in the denominator, n minus 1 and n minus 1 in the numerator. So my final answer will be n minus 1 over n minus 2. When we divide, we're going to multiply by the reciprocal, so I'm going to rewrite this as 10x minus 9, and I'm multiplying by 6x minus 54 over 1. If I were to factor out, I could factor out a 6 from both 6x and 54 to get x minus 9 over 1. The x minus 9 and the x minus 9 cancel. I'm left with a 1 in the denominator. And so I get 60x. This one here, I could have 10 divided by, I'll factor out 10 from 10b and 10 from 9, left over with b plus 9. And I'm multiplying by 6b over 1. 10 and 10 are going to cancel, I'm left with a 1 in the numerator, and I get 6b divided by b plus 9. Like we talked about, I'm not showing the parentheses here, but we want to think of this as one number. We can't divide the 6b and the 6 here. Or sorry, we can't divide the b in the numerator and the b in the denominator because 9, this term doesn't have a b. In number 9, two numbers that multiply to 42 that combine to negative 13 are going to be x minus 6 times x minus 7 divided by, I can factor out 3x in the denominator, and I'm multiplying by the reciprocal, so this is x minus 1, and then if it's 2x minus 2, this is 2 times x minus 1. So I can divide the x minus 1 and the x minus 1, I'm left with a 1, x minus 7, x minus 7. This is going to be x minus 6 divided by 3x times 2, or x minus 6 over 6x. For number 10, we're going to be adding. Now in this example, we have rational expressions that have a common denominator. So when I add these, I'm just combining the like terms. It's almost like v minus 5 plus v plus 2 divided by 10v minus 5, or 2v minus 3 over 10v minus 5. Occasionally, you'll add or subtract some rational expressions, then the sum or the difference, like what you're left over with for the rational expression, can be simplified afterwards. In number 11, we have 2b minus 2, and then minus 2b, all over 9b squared minus 9b. 2b, take away 2b is going to be 0. This is negative 2 over 9b squared minus 9b. I don't have to factor here, right? I could factor out a 9, but it's not required. Like this would be an answer for this in the simplified form. In number 12, I have two different terms, or two different denominators. So I'm going to multiply by the least common denominator. In this case, it would be like 3 over r minus 5 plus 4 over r plus 1 times r minus 5 times r plus 1. If I multiply 3 over r minus 5 times, or actually I'll write it, 3 r minus 5 times r plus 1, these cancel and I get 3 times, Let me back this one up a little bit. So I want a common denominator. There's going to be r minus 5 times r plus 1. So to have r minus 5 times r plus 1 in this first rational expression, I'm multiplying by r plus 1 in the numerator and r plus 1 in the denominator. The same thing, I would have 4 times r minus 5 divided by r plus 5 times, r minus 5. Times r plus 1. So I can distribute and write this as the sum all over r minus 5 plus times r plus 1. So 3r plus 3 plus 4r minus 20 over r minus 5 times r plus 1. Or 7r minus 17 over r minus 5 times r plus 1. And I'll do a couple more. And then also, too, the answers, and I don't know if everyone's always aware of this, I have the answer key in the back here that you can reference for what we're looking at. Did I mess up? Oh, I did mess up. Sorry, I did not see the R on there. Let me back up on this one. We do want to have the common denominator. I forgot to write an R. This will change the math on it if it's r minus 5. So, sorry about that one. This is 3r plus 3 plus, and now this is 4r squared minus 20r. All of this is still going to be divided by r minus 5 times r plus 1. I can combine the like terms, so 3r minus 20r is going to be 17r. I'm going to write this in standard form, so like 4r squared minus 17r plus 3 divided by r minus 5 times r plus 1. Sorry about that. But like I was saying, we've got the answers in the back that you can use as a reference. I'm going to make another video for the second half of this. And I posted the My Math Lab and this review on Blackboard.